Okay, so we are going to continue with the problems we were working on, and we're going to see E. Okay, so we're going to go with E, and I'm going to write it down here, and just please let me know if I've written it down correctly. So E says that we've got f of x equals minus 0.5 square root of 1 minus x plus 1. Is that okay? Is that the one?
Yes.
Okay, good. So this is a tricky one. Okay, this is if I were to put level of not necessarily difficulty, but trickiness. This is a tricky one because this has a few things that we need to consider. So I'm going to go slow with this one. And if you guys have any questions, then let me know. First off, can somebody tell me what is something that we can notice in this function that the other ones didn't have?
The square root.
Well, let's see. Yeah, it's the first one that's got a square root. That's correct, Andrea. So let's start off there. Very good, Andrea. Let's start off there. Remember the reference graph. So if it's a square root, the reference graph goes something like this. Is that is that understood by everybody? Okay.
Yes.
So the reference graph, and remember that we're going to be looking at the graphs. I think that's slide 25 or something like that. That's the reference graph, and that's because we've got a square root here. Okay, we've got a square root here, and that gives us that reference graph. Okay. Now, so that's good. So the first thing we notice is we've got a square root there. So now we've identified the reference graph. What is another thing that this one has that the other ones didn't, that we might have a problem with?
That is minus 0.5.
Well, that's another thing that's good, Estrella. The other examples, bless you.
Salud.
Please, what the other examples we had done didn't have anything that was multiplying by a fraction, right? So there's a minus 0.5 there. If it's a 0.5, what does that mean? Does somebody remember? If we're multiplying by a 0.5, what does that mean?
Oh, Andrea was, I remember Andrea said that it was not going to stretch, it was going to, what was the other?
Compress.
It's compress, correct. Very good. So if it's not stretching is when it multiplies by a number larger than 1. This is multiplied by 0.5. So instead of stretching, it's going to be compressing. Good. We've identified a couple of things that are different.
So
Good.
the difference is the plus 1. One.
No, because the other examples we had done, the plus 1 is a vertical shift. We had already done some that had vertical shifts. But what's something else that's a bit different from this one?
This one we are going to reflect it in the y-axis, not in the x-axis. No, in the x-axis, not in the y-axis.
Well, let's break it down a little bit before we get to that. I hope you notice, or everybody notices, that we've got a minus here. This is different because the x has a minus next to it. You notice that? In all of the other examples that we had, the x was positive. Okay? This is the first example we're getting where the x is negative. Okay? And that's important because that's going to generate a specific type of reflection. So before we move on, does everybody see that?
Yeah.
Okay. Now, we need to do something when this occurs. okay? And I might put some of these in the exams just to throw you off a bit. But we need to do something when this occurs, okay? Since we've got a negative in the x, then we're going to reorganize this function a little bit so the reflections and the shifts are a bit clearer and correct, or else we might get confused and we're going to do shifts and reflections that aren't correct. So whenever we have this situation where there's a minus in the x, what we're going to do is the following. I'm going to write this down in a different color. We're going to rewrite the same function. And another thing, notice that the minus is inside the function. That's the tricky thing. It's inside, it's not outside. If it's outside, it's not a problem. We already know what type of reflection to do and how to do the shifts. But since it's inside, we have to be careful with that. So it's going to be minus 0.5, and then I'm going to have the square root, and I'm going to do this. I'm going to bring out a minus because I need to identify that the minus is inside the function. And I'm going to multiply everything that's inside here for this minus. So if I bring out a minus here, what is this going to turn into? Is it clear to everybody that this is equivalent to having minus x minus 1? The only thing I've done there is reorganize the function a little bit. Why? Because of this. Okay, I brought the minus out, so the minus is multiplying everything that's inside the function. Okay, was that clear? So let me, before we move on, let's say that I give you this. I don't know, divided by elevated to the 1/2. Let's say I give you this, okay? And I tell you to graph that. There's a couple of things you need to notice. One is that what does the 1/2 represent? The 1/2 represents the root. And the other is that there's a minus in the x, okay? And so we need to reorganize this, and this would be equivalent to having, first off, the square root of 2 minus x. And then we're going to bring the minus out and have it as minus, in this case, x minus 2. So whenever we have a minus that's multiplying the x, it's recommended, and again, this is just a recommendation, it's recommended, so we get a little bit less confused, to bring the minus out so we clearly identify that there's a minus inside the function. And why is the minus inside the function important? Because the minus inside the function generates a certain type of reflection, which is a reflection around the y-axis, okay? So it's important to identify that, okay? So once we've done this, before I move on and start doing the graphs, is it understood what I did here? The only thing I did is bring the minus out and factor it, so now we have this all multiplied by a minus, okay? Okay. Now let's look at this new reorganized function and see what we need to do. And remember, something that we've talked about is that the order in which you do the steps, you can do them in any order. You're gonna get the same result anyway. I'm gonna do it in a particular order. So, and I'm gonna color code this. Okay, so we identify what we're doing. So the first thing I'm going to do is that I'm going to notice that there's a minus here. Okay, and a minus is going to be a reflection. Okay, around the y-axis. Remember that when the minus is inside the function, the reflection is around the y-axis. Why is that? Because the x's that are positive are now turning negative, and the x's that are negative are now turning positive. And so what's happening here is that from the original function, I'm going to flip it to the other side. That's the pink part, or that's the effect of the reflection in the y-axis, which is basically the minus that we have there, okay? So that's one thing. What is another thing that we can notice? Is it clear that we have a shift? This -1 that I have here, what type of shift is that going to generate?
To the right.
To the right.
It's going to generate a shift to the right. That's correct. This is a shift. And it's a shift to the right. Okay, very good. And how many units is that shift going to be?
One.
One unit, right, perfect. And so now what we're going to have is this. Okay, let me do that a bit more marked. Okay, again, we're doing sketches. I don't know what this intersection is right now. We're just doing a sketch. Okay. Next up, we are going to have we've got the 0.5 here. And the 0.5 is a compression, okay? So I'm gonna do the compression in the same graph, just so we know. So the purple one is the one we had. The compression means it's flattening out. So the compression is gonna be the green one. The green one is gonna be a little bit more flat, okay? That's the compression that we have for the function. And next up, we have minus here. What is this minus going to generate? It's going to generate another reflection. But that reflection in what axis is it going to be? It's going to be in the around the x-axis. So now what we're going to have is a reflection along the x-axis, and we're still here at 1. And lastly, I'm going to need another color here. Let's try yellow. Lastly, we've got this +1 here. Okay, what does the +1 generate?
Up, a shift up 1 unit.
Shift up, correct. We've got a shift, and this shift is upwards. Okay, and so what we're going to have in the end is something like this. We've got I'm going to exaggerate here a bit. We've got the 1 here. We've got the 1 here, and this generates a new point here. And so what we're going to have is a graph that goes, draw that a little bit better. We've got a graph that goes from here to here, okay? It crosses there. Now that would be the final graph. I want us to take this example to kind of relate a few things that we had seen in the previous topics. So what's the things I want to relate? And I'm going to draw them in red. This is the sketch, so this would be the end of it. Well, one question, is this even, odd, or neither? And why?
It's
Neither.
It's neither, correct. We don't have any sort of symmetry. We don't have symmetry with regards to the y. We don't have symmetry with regards to the origin. Okay, so that would be the end. That would be the end of this problem. This is neither even nor odd. Okay. Now, let's add something to this problem so we can practice some things. So we're done. We're done with what the problem was asking us to do. However, if we were to be we were trying to be a bit more specific in this sketch, I might want to know where, and I'm going to put a question mark there. Is it clear that the graph somehow crosses the y-axis and also somehow crosses the x-axis? Right now, we don't know those two values. This is going to be a question in the exam. Those points where the graph crossed the x and the y-axis, what are those called? We had already seen that before, previously. What are those called?
The intersects.
Correct, yes, very good. Intersects. Those are the intersects. So let's say that well, I have these, if you heard a sound there, for some reason in my cell phone, I've got apps for BBC News and CNN and etc. And for some reason that I haven't reconfigured, whenever I get a notice from BBC or CNN, the ringtone is very dramatic, like or something like that. And this is, I just found this interesting. This has nothing to do with math, but French President Macron has announced a curfew for Paris and 8 other cities from I think 9 p.m. to 6 a.m. I don't know if you've been up to date with the news, but so Europe kind of started reactivating and doing some things, and now they've been hit by a new wave of coronavirus situations there. So now many countries in Europe are having to shut down again. So that's happening around the world, and it's worrisome. But let's get back to things that are extremely more fun or funner than the coronavirus, which is functions and stuff. So, so like Giselle mentioned, these are called intercepts. So what are the intercepts for this function? We don't know them, okay? Let's try to find them just so we can practice. Something that we might do, and I'm gonna try to do some exercises with that, but I could give you a problem. So for example, I can give you one problem where you have to apply everything we've seen in Unit 2. So for this problem, I could give you this problem and say, sketch the graph of the function, give me the domain and the x and y intercepts. For one problem, we would need to do everything. So does somebody remember how we find the intercepts? I'm going to write that down here in red, and we're gonna find those values.
You need to know where the graph crosses in which points with the x and the y axis.
Mm-hmm. So if we were correct, Andrea, so if we were to want to find the x-intercept, what would we need to do? So if we were to find the intercept in x, meaning where x crosses here, to find the x-intercept, what do? We make y equal to 0. Okay, so if we make y equal to 0, that means that minus 0.5 square root of, I'm going to use the original function, 1 minus x plus 1 equals 0. Okay, and I need to find the value of x for this. Please do that. Do that in your notebooks, and somebody tell me the answer to that. We need to find the value of x when y equals 0. I'm going to give you a few moments to do that while I explain the y-intercept. To do the y-intercept, what would we need to do to find the y-intercept? Anybody?
Substitute x with 0.
Correct. Perfect, Alejandra. To find the y-intercept, now we're going to make x equal to 0. And if we do that, we find a value of y. So y is going to equal minus 0.5. Oh man, my writing is horrible today. Square root of 1 minus 0 plus 1. Please find the value of y. I'm not going to do that here, though, because that's algebra. You should be practicing algebra. So somebody tell me here the value of x, and somebody tell me here the value of y that you find, please.
Teacher, I have a question.
Yes, go ahead. Yes, and please remember to turn on your cameras when you ask, please. But yes, go ahead. Yes.
I know, I already noticed something.
Okay.
For y, for
I love
y
it when
0.5.
people answer their own questions. I'm sorry, who's talking? Diego, I think.
Yes, for
Diego.
y is 0.5.
Perfect, Diego. Perfect. Thank you so much. Y is 0.5.
And x-intercept is minus 3.
Correct. Perfect, Estrella. Perfect. Now, perfect. Thank you very much, Estrella and Diego. Now, let's look at the graph. Are those two values congruent? Do those two values make sense with the graph? I'm hoping they
Yes.
answer. Yes, this is minus 3. Oops. This is minus 3. And this value here is 0.5. Okay. So it's congruent with the graph. If I would have gotten different numbers, for example, if the x-intercept were 10, for example, that wouldn't have made sense. That wouldn't have made sense because if the x-intercept were 10, that means that we would be over here on this side, and the graph doesn't go there. Is this part clear about the intercepts? We're going to add something else to the problem, also to kind of review things that we have in theory already, not in theory, we've already seen before. I'm going to ask you something now. And I'm going to put everything that's in red are things that the problem didn't ask us for, but I could ask them. Can somebody tell me what is the domain
From
and the range? Give me a moment, Diego. The domain and the range for this function. Now go ahead, Diego. Let's look at the domain first. What do you think the domain would be, Diego?
from negative infinite to 1.
Correct. Perfect, Diego. Negative infinite. Now, before I finish writing this down, Diego, can you help me out with something here? Can you please remind us what's the definition of the domain, or what a domain is?
Oh, I forgot. I have it.
Well,
I think
Diego,
by,
go ahead.
I don't know.
Well, Diego, this is hugely important, Diego, and let's talk about this. Remember that when I've been talking to a few of you guys, and remember to turn on your cameras, please. So, Diego, if we're talking, just please turn. Okay, this is hugely important. I'm going to give you a spoiler of season 1 of engineering, and the spoiler of season 1 of engineering. Guess what? We're not teaching you math, programming, chemistry, or information organization or anything like that. What we're trying to teach you guys is how to think and solve problems. So it's very interesting. I asked what the domain was, and Diego, you gave a correct answer. That's correct. from minus infinite to 1. Before you try to find the definition of a domain, let's try to relate the knowledge. How did you find, or how did you define that the domain was from minus infinite to 1?
Well, just by looking at it,
By looking at the graph, right?
yes.
That's correct. Why don't we have values after 1? What does it mean that we don't have values after 1?
Because if you pass x equals 1, if you pass number 1, the number 1, it will be an error.
It would be a negative
There's
root, right?
It will be a negative root.
So let's try to join things together. If I ask you in the exam, Diego, what's the definition of the domain? Remember, Diego and everybody else, it is all of the possible real values of x that a function can have. So a negative, if I put a negative minus a negative 2, for example, that's not part of the graph. The graph cuts off here. That means that the negative 2 isn't going to give me a valid or a number that's valid for the function. So the definition of the domain are all of the values of x that a function can have. Okay, remember that. Okay, so thank you very much, Diego. Now, one last question before we go, just to leave you off. After this, I'm going to leave you off the hook. You said that it's from minus infinite to 1. Question, Diego. Is it a closed interval or an open interval? Meaning, am I including the, and I'm picking on you because you've got the Patriots hat on. Maybe if you didn't have the Patriots hat on, I wouldn't be asking you. I'm joking about that. Please don't be sensitive. What would be if it's the one, would that be a closed or an open interval?
0.5. I will say it's a close.
Correct.
Interval.
It's a closed interval because if I substitute the 1 in the function, it's not a problem. If I substitute 1 in the function, it's a real number. So this would be a closed interval. Okay. Thank you very much, Diego. Well done. Perfect. Perfect. Now, questions about the domain before I go to the range. Did you notice that we didn't have to do any calculations, that Diego didn't have to do any calculations to find the domain? We could do the domain using an inequality, but we can also look at the domain looking at the graph or the sketch of the graph. Can somebody identify, maybe using the same logic, what seems to be the range for this function?
Is it the same as that domain?
That's Viviana, right?
Yes.
Okay, please remember to turn on your cameras or else I can't see you or know who's participating. So Viviana. Okay, yes, that would be correct. So you're saying that the domain goes from, the range, I'm sorry, goes from minus infinite to 1 also. How did you get to that? Can you kind of talk us through how you got to that conclusion?
Because the graph starts from 1 in y, and it keeps on going, never ends.
That's and it keeps on going downwards. That's important. It keeps on going downwards, and we haven't marked an ending to the graph. So if we look at the graph, perfect, Viviana, that's perfect. So it goes from, you're not free yet, but it's perfect up to this point. So if we look at the graph, it's going from 1 downwards, and so the range would be from minus infinite to 1. Now, what would the definition of the range be? If I were to ask you in the exam, Viviana, tell me, define what a range of a function is.
All the possible numbers of what?
Perfect. Almost perfect. Yes. All of the possible values of y. No, it's 99.999% perfect. It's all of the possible values of y according to the domain. Because remember that the domain and the ranges are related. So the domain is all of the possible values of x. The range is going to be all of the possible values of y given the domain. Okay, perfect. Thank you very much, Viviana, that was great. That was perfect. Viviana and Diego are the, if this were a class not in university and we were back in time to when I studied, you guys would have a little stamp of a B in your notebooks. You don't even, you guys are too young to know about that, right? You didn't get B's and turtles and stuff, right? When I was in school, in primary, secondary school, and so K through 12, but earlier on, you did your works, and if you did them well, you got a B. You got a stamp of a B, or not. Or if not, you got a stamp of a turtle if you did it too slow. That was the type of feedback we got back then, and even but it helped. So with this problem, I'm trying to relate everything we've seen up to this point. Okay, and this is kind of a complicated one, or a more of a complicated one. I tried to do it with this one precisely because it's a complicated one. The others were a bit easier. So questions with this before we move on to the next set of problems that are, that the next set of problems have different, it's the same things we're doing, but with a different modality, which is basically when we're already given the graph and we're doing some things to the function. Questions with this before we move on? Okay, I'm going to assume that we're okay up to this point. Okay. I'm going to clear this drawing in 5, 4, 3, 2, 1. So if you have questions, we're going to have to draw things again. Now we're going to be looking at the next set of problems. Okay. And the next set of problems now are these. Now we're given a graph. And the graph is the one that's shown here. This is the graph we're given. Okay.
Teacher, that is what we had to do in the homework task. Like there were some problems like that one, right?
Yeah, yeah. You were given a graph of a function, and then there's a bunch of examples that say we've shifted it, we've moved it, we've reflected it, and we're trying to move the graph around. So yeah, I even got this image from one of the homework tasks, but the examples are different. So it's one of the ones, it's one of the graphs in the homework task, but the things we're going to do with it are a bit different. So this is the graph we're given. Okay. Okay. And now what we're going to do is that we're going to start doing some things to this graph. And basically we're going to be practicing shifts, reflections and compressions and stretches and etc. with the graph. Okay. So I'm going to switch over to the canvas and we're going to start working on that. Okay, here we go. So the first thing I'm going to do is I'm going to leave up here as a reference. I'm going to put up here, I'm going to put the original graph, just as a reference. Okay. And these are sketches. So the original graph goes something like this. Okay. It's a bit more marked to the y-axis and a bit more separated from the x. So that's the original graph that we're going to be kind of playing around with. Okay. And now let's see each of the problems. So let's start off with A. I'm going to write them down here. So the other important thing is that this graph here, this graph is f of x. Okay. We don't know the mathematical expression of f of x, by the way. We don't know what that is. We just know that is that graph. And so for the first problem, we are given that we want to graph or do the sketch of the graph, but now we've got f of x minus 2. Okay, We're given y f of x minus 2. And we need to see how the new graph behaves, okay? And so let's look at that. What we've got here is that we've got the original graph and then we've got a minus 2. What is the minus 2 going to generate in the graph?
Go down 2 spaces.
Perfect,
Okay.
correct.
Yes.
There. So this is going to be a shift and a shift downwards, okay? And so if it's a shift downwards 2 units, like Diego mentioned, that means that we've got 1, 2. Now the new graph is going to, the reference, remember that we always take a reference, the reference is going to be the origin. So now the graph is going to go through here, kind of like that, okay? By the way, I'm just drawing this. I'm actually going to draw it again. We don't know. So I didn't want to draw it in a way that seemed that the x-axis was an asymptote, because we don't really know that it's an asymptote or not. That information isn't given in the graph. So I didn't want to give the impression that it was an asymptote. So it might cross the x-axis at some point, okay? This would be the new function, which is f of x minus 2, okay? Questions with this one? Nope. Okay, I'm going to do it here in the same one. Let's now look at B. So B says now that y equals f of x plus 3. Okay. And so,
Professor, it's minus f.
oh, thank you so much. Thank you so much. I'm going to do 2 things there. So that's important. Minus f. And we'll, after this, we will, after doing this one, we will take a break. Thank you very much for that. I think it was Viviana, right? Viviana or?
Yes.
Viviana. Thank you, Viviana. So it's minus fx of 3. So 2 things are happening here. The first thing is that we've got minus fx plus 3. We've got an x plus 3 here. Now notice something. Remember when I've been mentioning the inside and the outside. So notice that the plus 3 is inside the function, okay? So if it's inside the function, then what does that do, or what effect do we have there?
It's to the left.
It's a shift because it's inside, and it's going to be a shift to the left, okay? So that means that so we're going to have a shift to the left. That's going to be 3 units here. And so that's going to mean that now the function, the new reference is going to be the minus 3. And so the new function is going to go something like this, okay? And the next thing that we see here is that we've got a minus here. So is it clear that the minus outside the function is going to generate a reflection, okay? And that reflection is going to go along the, it's going to be reflected along the x-axis. So we've got the minus 3 here. And so now the reflection is going to be something like this. Okay, so we're flipping the graph along the x-axis because it's a reflection that's outside the function, or the minus is outside the function. Okay, so first we shifted it 3 units to the left because of the +3 here, and then we flipped the graph along the x-axis. Okay.
Professor,
Yes, please.
the reflection is going to be in the x-axis and not in the y-axis.
Okay, why is that? When the minus is outside, it basically, outside the function, it means that whatever is positive in the vertical now turns negative, and whatever is negative in the vertical now turns positive. Okay, so this minus means that anything that was here on top is now going to go to the bottom. So the minus outside the function always is going to reflect on x. The minus inside the function is going to reflect on y. So if you have a minus outside the function, all of the positive y's are going to turn negative, and all of the negative y's are going to turn positive. If the minus were inside the function, and we're going to see an example of that in a bit, the positive x's turn negative and the negative x's turn positive. Okay, so always when it's outside, the reflection is going to be on the x-axis. Okay.
So if the x was negative, the reflection would be in the y-axis.
Correct. And we're actually problem D. We're going to see an example of that with problem D. Okay. Okay.
Okay, thank you.
Okay. Thank you, Viviana. So I'm going to pause here so we can go to a break, and we will continue. And I'm also going to pause the recording. Okay. And we'll be back in 10 minutes. I'm not going to put the timer so this doesn't get erased. So in 10 minutes, we'll be back. Thank you. Okay, so any questions with this, with these two problems? No. Okay, so I'm going to move on to the next one. So I'm going to leave the reference function here on the top, and I'm just going to clear these up. Maybe even use some of these graphs so I don't have to draw them again. Okay, now let's go to problem C. Okay, so I'm going to write it down here, and please let me know if everything's correct. So problem C is y equals 1 minus 0.5 f of x. Okay. Now, what is the first thing we notice with this one? Well, we've got a 0.5 here. So this 0.5, what is the 0.5 going to generate in the function?
A compression.
Compression, correct, perfect. Thank you, Andrea. It's going to generate a compression of 0.5. This is a compression. And so what I'm going to do here is I'm going to write the original function in blue. And so the only thing that's going to be happening there is that the compression is going to make this kind of sort of flatten out. Okay. And so the compression is going to generate something like this. Oops. Try to graph this apart. So first off, this is going to be lower here. And also over here, this is also going to be like this. So the compression is going to generate, that's going to try to get closer to the, a little bit closer to the x-axis. Okay. And again, these are, we're just doing some sketches here. And then we've got the minus here. here, what does this minus create?
Reflection.
A reflection, correct, Viviana? And where is that reflection going to be?
X-axis.
The x-axis. This is correct. So now the function is going to be something like this. It's going to be reflected or flipped around the x-axis, and this is still kind of a curve, but it's been a bit flattened out. And lastly, we've got the 1 here. What is this 1 going to generate?
One shift up.
Correct. This is going to be a shift, and the shift is going to be upwards. And so that means that now the graph is going to move upwards 1 unit here. And so what we're going to have is, instead of the reference being the origin, now the reference is going to be the 1. And this could eventually cross the x-axis. We don't know, okay, but it could. And so that would be the graph. And again, we did 3 things there. We did the compression, we did the reflection, and we did the shift. Okay. Questions with this one? The next one's got a bunch of complications there and things we have to do. Well, not that many, but questions with this one before we move on to the next one. Okay. If there are no questions, then we will erase these in 5, 4, 3, 2, 1. I'm going to keep these. It's actually practical to leave the axis there. Okay. Okay, y is going to be, in this case, f of 2 minus x plus 1. And what do we notice there in this one? What's one thing that kind of pops out there?
The x is negative.
Correct. Very good, Viviana. So the x is negative. So we've got a negative x here that we have to take into account. Okay. And what did we say we were going to do when we had that situation? We're going to rewrite the function just so that negative is clear, and we do the shifts. We do the shifts and whatever reflections and things we're doing, we do that correctly. So what we're going to be doing is that I'm going to say f of, I'm going to bring a minus out. And if I bring a minus out, this would be x minus 2. All of this is still inside the function. I'm just exaggerating the parentheses there. Plus 1. Okay. So again, why am I doing this? I'm doing this because I'm trying to represent the minus outside the function, so we have the reflection and the shifts correctly. Okay. And so this minus that we've got here, what is that going to generate? This minus here.
Reflection.
It's going to be a reflection, correct, Viviana? And it's going to be a reflection, in this case, with regards to what axis?
Y-axis.
So the y-axis. So now the function, instead of being on this side, is going to be now on this side. Oops. it's going to be reflected, and the reflection is going to be with regards to the y-axis because we've got a negative here. And then what do we see? We've got this -2 here. What is this going to create?
It's going to shift to the right side 2 units.
Perfect, correct, Estrella, thank you very much. So it's going to be 2 units to the right. Perfect, perfect. This is going to be a shift, and it's going to be a shift to the right. That's going to be 2 units. So now the reference is going to be the 2. So now this is going to cross here, something like this, okay? And lastly, we've got the +1 here. And so what is the +1 going to generate?
One shift up.
We're going to have a shift up, and that shift up is going to be of 1 unit. So now we're going to have a new reference point, which is going to be the 1 and the 2. And so the graph is now going to go through that point somehow. Okay. The reference points are always important because the original graph had a reference point, and that reference point in this case was the origin. It goes through the origin. Basically, like we were mentioning, whenever we do a shift, a reflection, a compression, or a stretch, we're basically moving the points of the graph. So it's important to find a reference point. So whenever we do a shift, a reflection, a compression, or a stretch, that reference point is going to be affected. And so we can draw the graph with regards to that reference point. Okay. Okay. Questions with this one?
Yes, I have a question.
Yes, go ahead.
If in the original the 2 was positive, no?
In the original one, the 2 was positive, but I'm factoring. So I'm grabbing this term here, this part that's inside, okay? This part that's inside is 2 minus x, right? 2 minus x. And so whenever we've got a minus in the x, what I'm going to do is I'm going to bring out that minus and factor it. So if I bring out the minus, minus times what generates the +2? -2.
Okay, -2.
And minus times +x generates the x. And so this is the same as having x -2, okay?
Okay.
So when you do that step, and there when you do that step, what's going to happen always is that the number that you're adding or subtracting is going to change signs automatically. And that's important because if we don't do that, the shift that we generate isn't going to be the correct one. Okay. So whenever the x is negative inside the function, that means that everything inside the function, we have to consider it as negative. And so we need to change the shift. If we would have left the 2 as positive, then the shift would have been to the left, and that would not have been correct or congruent with the graph.
Yes, I did it that way to the left. Thank you.
So that's why we're doing these examples. So there might be a few of them that have that. So just remember that that step. Okay. Okay. Good. Thank you, Andrea. Any other questions with this one before we jump to the last one, actually? Nope. Okay. Questions in 5, 4, 3, 2, 1. I will begin erasing them. just indulge me. It's fun. It's fun for me. Okay. Let's go on to the next one, the last one, actually. Here we go. So E is the last one. E is Y equals minus 3F of X minus 2 plus 4. Okay, we've got a bunch of things happening here. So let's go at them step by step. So the first thing we see here is a minus 2. What is the minus 2 going to create?
A shift to the left.
Shift to the left. Perfect. Yes, that's perfect. Yes. Shift to the left. Perfect. So we've got a shift to the left. So now we have nope.
To the left.
No, no, no. It's not to the left. You're
right.
It's right. Correct. I'm just about to. I was just about to draw a few things that were extremely incorrect. Shift to the right. Remember that when it's negative, it's in the inside of the function. It's to the right. When it's positive, it's to the left. So it's a shift to the right. Okay. Oh, I'm sorry, Giselle. You said right. You said left, but you actually meant my left, which is actually right. Right. So you were saying
Yes,
it correctly.
Professor.
That was it. That was it. That was exactly it. So everybody's correct. So we've got a 2 here. And what's happening there is then that the graph is now going to be going through here. Something like that. Next up, we've got a 3 here. What is the 3 going to generate before the minus? What is the 3 going to generate?
A stretch.
It's going to generate a stretch. That's correct. And the stretch just means that the function is going to try to it's literally like I'm pulling the function upward. So now instead of having this, we're going to have something like this. Okay, I'll exaggerate that a little bit more. It's kind of going to be stretched a little bit. And then we've got a negative here. And so what is the negative here outside going to generate?
A reflection in
A
X.
reflection in X, correct. This is going to be a reflection in X. So now we're still here at the 2. And we are going to generate a reflection. And so what's going to happen there is that now we're going to have something like this going here. Okay, it's basically flipped. This is eventually at some point it's going to be crossing the y-axis. And lastly, we have got a plus 4 here. What is this plus 4 going to generate?
Or
Shift
unit.
up.
A shift up, and that's going to be 4 units. I'm sorry. So now we're going to have a new reference that is going to be here in 2, and we're going to have a 4 over here because it's going to be 4 units up, and this is going to be our new reference point. Okay. And it's going to go something like this. Okay, that's going to be the graph. I'm exaggerating a bit, just stretching it out a bit more so we can see how it goes. So eventually this is going to cross the y-axis. Okay, so this would be the complete, the green one would be the complete graph for this one. Okay, questions? Okay, so this kind of rounds out the set of examples that we've got regarding the examples we've got regarding these functions. Okay, I'm going to stop the recording.